This is the explanation about the Lab 6 railroad in Unit 1. I'm going to go over all the parts briefly. First, if I start from the beginning of the code, for the A star and bidirectional A star, you are going to copy your heap particle code into this file. Then calc edge code is already given, but you need to understand how this code is working. This code is using the longitude and latitude, and by using the miles, it is calculating the distance, the circle distance, great circle distance by using the law of cosines. So in this class, this part is given, but when you take the AI class or other algorithm class in the upper class, when you go to college, then you probably need to be able to calculate by yourself and write this code. Then make graph. This is the most important part of this lab because you are going to make all the graph first, then you are going to just use it. For example, the edge cost, we are going to pre-calculate all the edge costs, then we are going to just search it by using the dictionary, so it will save lots of time. Just one full loop, then you're going to calculate again later. The neighbors is the same thing. If you store all the adjacent and all the neighbors in one place, then if you just look at that, it's going to save lots of time. Node to city and city to node are very important to display path, then node location. This one is having the real position of latitude and longitude. So we are going to use this node location for our distance calculation. It is needed. And also we are going to have a draw the map. So map dictionary is given, but this part, the code is given. So after you are done node lab, you can just uncomment this green part. What this one is doing is it's going to do scale it for the 800 and 1200 pixel screen. So if your screen is much bigger and if you want to look at as a bigger window, you can change the scale numbers. Also, if you want to change the scale number, you have to scale, modify the latitude and modify the longitude too. As a scale 0 to 1. And this one is using our real latitude and longitude. We already know some information like North America's range of the latitude and longitude, so you can also give some scales by yourself. Now if I come back to here, node text file has node value, and locations, latitude and longitude. So you're going to see 3 things per line. So we are going to get node value, y coordinate, x coordinate. If you open the node city text file, there are only 50 cities information are there. Only big city has a city name and small city has only node name, node value. So we are not going to have all the cities for each node. We are going to find each line. Each line has a node value and city name. So you are going to store into the node to city and city to node. There's one thing you need to care of. City name is sometimes not one word. It can be multiple words. So when you read every values, then only first one is guaranteed as a node value, but the rest of them should be your city name. In the edges has 2 node names, 2 node values on each line. So you are going to read 2 nodes. Then you are going to check if node 1 is in neighbors. So if node 1 is in neighbors dictionary, that means you are going to just add node 2 as a neighbor. If node 1 is not in the neighbors, we're going to make a new set or list, then store node 2. Vice versa, because N1, node 1 is a neighbor of node 2, and node 2 is also neighbor of node 1. And also, we are going to calculate the edge cost here. So you are going to calculate the edge cost, then you are going to put this edge cost to both direction, because this is a bidirectional graph. You're supposed to add node 1 to node 2 edge and also node 2 to node 1 edge. Now, distance heuristic can just use the given method to calculate edge cost. So node 1 to node 2, you are going to get the direct distance. Display path is a little bit different because display path will print the city names of the path. So you are going to go through all the paths. Then whenever you see the city names, because graph 1 is the node 2 city, if you find something in the graph 1, you are going to add the city name into the path and return the path into the path. That is what display path is doing. Generate path is a helper method of the BFS and by BFS. So in here, you are supposed to do two things. One is you are going to make the path by starting from the state until it meets string S. Then at the same time, you also need to calculate the cost up to there. Because each edge has a different cost, you cannot use the length anymore. So you are going to use graph 4, which has all the edge cost. Then you are going to find each path cost, then each edge cost, then you are going to add to your total cost. And finally, you are supposed to return path and cost. That is what generate path does. Now, draw line is given, then you can refer draw line, or you can use a draw line when you draw the final path. Final path means when you find the final solution, the solution will be the path from a city to another city. Then you are going to draw this city to city on your map by using color red. That's gonna be your final path. Then you can use the draw line here. And draw all edges are given. This one is finding all the edges in the graph 4, because graph 4 is all the edge information. You are going to draw it as a white color. So actually, we are not using the background, the picture. We are going to draw the background before we start each search. BFS is given. So at the beginning of the method, it is making the new Tkinter window. Then it gives a title. Then have a canvas with the color. You can think about root is the J frame, then canvas is the J panel of the last year's one. Then maybe freshman year, draw all edges with the white color will be done first. So that is this draw all edges. After those things are done, now you're gonna start your BFS algorithm. One thing is, if I want to draw the line. So I want to see how much explored by using this algorithm. So it is a drawing with actually yellow color for BFS. But if I update my window each time, it's gonna take forever. So there is a counter. You can decide the speed, how frequently I'm going to update my root, my window, my graphic. BFS is also like a traditional way. So you have a frontier and explored, and when you pop 0, that means pop the first value from the frontier. And if you check the goal test, then find adjacent, like a graph 3 is the neighbors. So by using the graph 3, you're going to find adjacent without searching it. Then you can just check if the current child or adjacent is not in explored. You are going to add to the frontier, and that's it. And by BFS is used. You can use it like this BFS for the by BFS. Algorithm is the same. You are going to pop from the front. Then you're going to check the goal test. Then you are going to expand the adjacent. And also you are going to draw a line. One difference is now you are going to start from the both direction. So I have frontier 0 and frontier 1, explore the 0 and explore the 1. Then to go frontier 0 and 1, explore the 0 and 1 each time, I use a variable k. Because level by level expansion is needed, I use the temp to store only current frontier. Then A star can use a heap particle you already made. Then you can start from the total cost as the heuristic value from start to the goal. So you may have a frontier and explored. Only one thing different from the BFS is whenever you find the better cost, you are going to update it. So if I find the better cost, lower cost, I anyway add to the frontier. And each time you have to calculate the past cost again and again. So you can hold the past cost at the explored. This is one of the way. If you hold past cost in the explored, your start will start from value 0. And each time you are going to add edge cost. Graph 4 is edge cost from the current state to the child or adjacent. So first time I start from 0, I add the edge cost from the start to first level child. Then by using that, I store this value into the explored. So next time I'm going to get it, pass cost up to the state. Then I'm going to add only one more edge cost, like a current expansion. That is my path cost. Then total cost is not the same. So on the frontier, you are supposed to put the total estimated cost. So path cost plus heuristic. There's another way you can do the A star. This A star is having in the explored the total cost. This cost is a heuristic value. So in this case, each time you are going to recalculate the path cost. After you get the cost from your frontier, the pop, that is the total cost of the previous level. Then you are going to subtract the previous level's heuristic, that is path cost up to the previous node. Then you are going to add edge cost from the previous node to the adjacent current child. This one is the path cost. And when you add heuristic of the child to goal, that means this is the total cost of this child. Only this part is different. In that case, you are going to compare total cost to update your frontier.